have Mekka Williams. She's the Director, Innovation and Solutions in the Office of the CTO at NetApp. Mekka is a technology leader with an extensive experience in software engineering and product development across various industries. Mekka and her team are currently focused on solution innovation and development in the areas of generative AI and developer workflows. So without further ado, Mekka, I turn it over to you.
Thanks so much, Christopher, and thanks for having me. This is one of my favorite topics, and a topic that I've had proximity to for some time. The fun and interesting thing about working here at NetApp and for being here so long and being in my current role is that I get to bring my years of software development experience into a kind of innovative space where we get to take a little bit of a different look at how we approach software development, as well as how storage might play into some of these spaces where we're not used to considering. So that's primarily what I'll be sharing today. If I can figure out how to share on Zoom, that would be helpful. Just give me 1 second. Okay. Can you see the slides?
Yes.
Okay, perfect. So that's what I'm going to talk about. Talk a little bit about DevOps on NetApp. Much of what I talk about may be familiar to you individually, but I really want to have this conversation about bringing the intelligent data management to DevOps practices. And very often folks don't think about how we might benefit from really good data management processes and storage native solutions within software development processes. So the agenda is there for you to read, but really we're just going to get into it. So research indicates that many environments still are not very comfortable or feel like they're doing a good job with right-sizing their environments for their workloads. I think the number is 82% that reported that they still struggle with this kind of combination. And it's around leveraging what's available, the feature sets within the technologies that they're using. And technologies change and update and modernize very frequently. And so how do you keep up, and how do you make sure you're optimizing your environment and enabling optimal productivity for your users? And this extends from on-premises to the cloud. And things like cloud and hybrid cloud bring an extra layer of complexity to this. They also bring additional feature sets. And it's this, this delicate thing to manage and keep balanced, but keep up with. And storage optimization can be like discovering a hidden treasure as you try to navigate your optimization journey. Many don't think of the robustness in feature sets and data management as ways to realize gains in optimization. So much of technology has advanced, and we take advantage of managed services. We defer to applications. Generative AI and the cloud have advanced so much that we do a lot of this outsourcing and deferring to the technology, basically, to run our operations. But I kind of want to bring it back a little bit and say there are some things that we can still do today, even in these more advanced environments, to get some of those gains, but we have to think about it from a storage perspective. Now, that does require knowledge and robust tool sets and automation, and those will be themes that you hear throughout the discussion. And hopefully I'll share some of those things with you today, and you hear something interesting that you could then go out and share, or things that hadn't been thought of putting together, right? Like I said, much of what I talk about should be familiar, and if not, great, there'll be new things for you to learn. But it's the combining, and my goal is not to give you a recipe or prescription that you can then go and just apply, blindly to any environment, or drop into environments. Um, the goal is really to inspire kind of this way of thinking more creatively about how to use storage and ONTAP feature sets and NetApp portfolio intelligently, but leverage the simplicity that comes with the features that are available to you, um, so that you may help organizations standardize on their practices, and also provide feedback into us so that we understand how we could develop, evolve solutions and products to help make that easier. Now, I'm not going to share, like I said, I'm not sharing prescriptive things. So a lot of what I share can apply to many scenarios and use cases, but a lot of this requires some customization. Excuse me, and I'll talk more about that later. But there is a conversation to be had about being able to drop some of these optimization packages, these end-to-end solutions, into environments. And that is another conversation. And Christopher, maybe we could talk about doing a talk about that later on as a follow-up or in the future, because that is also something I'm very interested in. So that category is more along the lines of platform and platform engineering. So just putting a pin in that if anyone's interested in that topic or has something to share. I mean, if we have time at the end here, let's do that, or you can certainly reach out to me afterwards. But again, storage can be this hidden treasure. I had a little animation. That's the only animation you'll see today. It can be a hidden treasure when seeking optimization and productivity gains in your environment. And this is true across workloads, absolutely across workloads, right? Storage optimization can bring the optimized performance, um, cost efficiency, scalability, and that's true for all environments. But specifically for DevOps, this translates into improved and increased developer productivity. And that's through things like enabling faster build and deployment times, reduce storage costs, which is an overall, which is receiving way more scrutiny today with folks running their CI/CD pipelines in the cloud. Increased reliability and availability, of course, which is necessary for all workloads, but is still really important for DevOps. And improved scalability as teams grow, as your deployments grow, as the demands for your services grow. And much like many organizations still struggle to right-size their workloads, this is true for DevOps as well. But something else is happening in the industry, and maybe you all have observed it, where organizations are very interested and focused on improving developer productivity. And you'll hear this language around improved developer experience, increasing developer velocity. There are new frameworks that come about to measure this. There are things like DORA, if any of you are familiar with that research group from Google that focuses on providing metrics, but things have emerged like Space and DevX. And generative AI is playing a big role in this with the advancements of GitHub Copilot that are targeting developer productivity improvements specifically. And one of the reasons that organizations focus on this is because it's been proven that when developer experience improves, there is a 30 to 40% reduction in the amount of time that it takes to launch products. This means faster time to market. This is bringing more value, quality software to your end users faster. And these are all the goals of DevOps. And it also results in a 15 to 20% improvement in product quality. And so these are all things that folks that are in the business of producing software are very interested in. But what does that have to do with storage optimization? Well, if you can improve a developer's experience And when I say developer, I'm talking about folks that write code for product, but also folks that write code for test, because today most of test engineers, QA engineers are also developers. Everyone's a developer now, right? It can improve the overall developer experience as well. So if a developer is spending less time wrestling or having to be knowledgeable of or working around infrastructure and configuration, that's more time they can spend working on actual software. And this has proven to increase sentiment amongst developers that they're having a good experience. It can also do things like reduce troubleshooting barriers, reducing complexity in the environment, and letting developers focus on the logic, their main value that they bring to the software development process is a key part of improving developer productivity. So all of those solutions that I discussed today, I'm not going to spend a whole lot of time talking about this in particular, but they apply to ONTAP running on premises, ONTAP running in the cloud, and ONTAP running across in hybrid configurations. This is important too, because while we have evaluated and considered storage optimization and how the ONTAP feature set applies to DevOps, primarily on premises. Historically, NetApp has expanded its portfolio into the cloud quite significantly, both with our marketplace offerings as well as our first-party cloud solutions. And so this is a really important point, that if you are evaluating configurations, environments that are in the cloud and on-prem or across both, you can bring much of the storage optimization practices, if you already have them established, or you can newly introduce those into both environments pretty seamlessly. And it's one of the value propositions of ONTAP's data management feature set. So let's get into it a little bit. I'm going to cover just a couple of scenarios, and they are by no means the total and complete list of ways you can optimize. But remember, my goal is to inspire. So hopefully this can give some good ideas. So let's take FlexCache, for example. Hopefully many of you are familiar with FlexCache. It's a sparsely populated cache from an origin volume. It requires a minimum ONTAP of a version of 9.5. Hopefully everyone is well beyond that by now, fingers crossed. And essentially it allows you to bring frequently accessed data, hot data, closer to the host, the client that is in need of access to that data. That's a grossly simple description of it, but it essentially it leverages flex volume technology to do this. And the benefits are naturally improved performance, because when the storage is closer, it has there are faster access times. It also reduces latency and network load, because there's no reason to go back to the origin volumes for frequently accessed files. And it's quite efficient, right? Because it is sparse. Only the data that is absolutely needed is in the cache. And in the cloud, this is really significant, right? Because reduced data footprint results in lower costs. And the ideal use case for FlexCache is read-heavy workloads, right? If you get into write-heavy, well, you may want to consider different solutions, but read-heavy workloads can benefit greatly, especially if it's a geographically distributed development team, and there's a lot of collaborative work that's happening, and there's a lot of sharing of large files. So this is, this can be a staple. We have lots of case studies and use cases available out there of development environments, dev test environments that benefit from FlexCache. A few other things about FlexCache. Fairly simple to provision. You just create a source volume, and then you create the FlexCache destination volume, and you peer the clusters, and you create the FlexCache relationship. NTFS and Unix style security are both supported, and it's a one of the staples in our feature set. And again, it's not that I'm introducing FlexCache to you, but really just leaning into how FlexCache helps with developer workflows. So an example use case in a dev test environment, and this is actually all of the use cases I share are in practice. So a geographically distributed development environment wants to burst to cloud to take advantage of compute in the cloud, right? Instead of ramping up on CapEx, which a lot of organizations are doing, they take advantage of compute in the cloud where they can burst and use what's needed, scale up, scale down, and just defer to OpEx for certain needs above a certain threshold, or for any reason that you may want to use compute in the cloud or even in another location. There are things like tool sets, libraries, test data sets, golden images. There's a core set of assets that many developer workflows need to share. And sometimes those files are very large. So if you're distributed, if you're in a distributed environment, you have to have a solution to provide consistency to your development environment. So everyone's working from a known version and set of files, and that they're sharing effectively and not, and everyone's no changes are honored, and that there's no discrepancy in versioning. And these are the things that help organizations go faster. So FlexCache enables this, right? You pre-warm the cache. It's kind of a one-time hit to get the cache set up and populated with those files that the organizations will access. But from there on, the organizations can share the files very effectively and efficiently. This results in reduced time to execute test cases overall end to end. And it's a really low cost way to scale your environments while providing the high availability. And again, all of these features in an ONTAP environment benefit from all the other added goodness of ONTAP. So the high availability, the high performance, the backup and disaster recovery functionality. So this is on top of those things. And in practice, and an organization was able to realize a reduced data footprint of 90%. So there are real live savings happening with FlexCache. And it's just one example. There are many available, and I provide some references to use cases in the back of the deck. Also, Christopher, I don't know if how the questions work, but if any pop up while we're chatting, of course, just feel free to interrupt me.
Absolutely.
Okay, cool. So that's a little bit about FlexCache. Let's talk a little bit about Flex Groups. So Flex Groups are, I'm sorry about that. So Flex Groups are volumes that contain several constituents that transparently share data traffic across systems. The constituents themselves are flex volumes, and they make up the actual flex group. And hopefully you're all familiar with flex vols. They're a core component of ONTAP data management. And flex groups distribute I/O operations across multiple storage nodes to ensure high performance and low latency. And the benefits here are that they enable scalability again, high performance, and they're very simple. This is a really good strategy to employ when you have workloads that require high capacity and high performance, or you have dynamic data intensive workloads. And again, they're ideal for collaborative and distributed environments. When provisioning flex groups, it is important that you you configure, you size the aggregates to support the anticipated capacity and performance needs. And our documentation and best practices guides can absolutely help with that. It's also important to monitor the performance when using flex groups because there's some overhead to that. But when you're standardizing practices and you're using automation and you have good kind of observability practices, this is not really extra effort that you need to make in order to integrate them into the environments. Flex groups automatically load balance, like I said, and this helps to prevent bottlenecks when any one node potentially becomes overloaded. They can scale up to 20 petabytes with individual constituents of up to 300 terabytes. But my disclaimer is that any number I say here today, please always refer to the ONTAP documentation, because that will be ONTAP version specific and it is always subject to change. So for accuracy, always check the docs. The 300 terabyte constituency number is associated with ONTAP 9.12.1. So again, this promotes consistency across shared storage, which is really important in developer environments. And if you are familiar with flex vols and organizations that use those, if for some reason they outgrow the limitations of flex vols, so they grow into a space where flex vols are no longer serving the requirements, they can, I think it's starting with 9.10, they can actually convert their flex volumes over to flex groups. And actually the sample use case that I'm sharing did just that. The team was using flex volumes for build servers, and there was some consolidation of build servers necessary, and the build server started to choke a little, right? It started to suffer build time decrease, the time it took to perform the build, to complete the builds, decreased by as much as 50% during peak times. So in order to address and remedy that, the team converted the flex volumes to flex groups, and they were able to realize an increase of 30% of the execution time and 20% increase in the build process improvement times. So these kinds of improvements of load balancing and distributing the load resulted in real and actual gains. And in this particular case, it avoided the need to purchase additional hardware and make better and more efficient use of the compute and configurations that were available. Now, there was a specific configuration for this particular flex group deployment, and I actually have a link to this case study in the references as well. There was one aggregate per node in a 4-node cluster using an AFF A800. And this environment was serving over 7,000 volumes. So like I mentioned earlier, right, there won't be, everything's not prescriptive, but you could take the principle, the premise of converting flex vols to flex groups and apply it to a scenario or a requirement within a DevOps software development lifecycle scenario to realize similar gains. So this is just one example of that, and there are many out there. So now I'm going to talk about flex clones, which hopefully it's one of your favorites, like it is one of mine, just because it comes up so often for so many reasons. It is so applicable for optimization in lots of ways, but it's definitely, it comes up often for optimizing dev test workflows. And a little disclaimer, we use flex clones here at NetApp. Actually, the last example is also based on NetApp experience. That use case is from a blog that our own DevOps organization wrote a couple weeks ago. So we continually, even internally, evaluate how to use our own feature sets to make our own engineering lives easier, to improve the developer experiences and improve productivity amongst our own developer community, which is one of the cool things, I think, because what is it? It's not the dog food one. It's the drinking our own champagne. That's what we do here at NetApp. So flex clones are another way to save, to optimize your storage. Flex clone is an instant writable space efficient clone of a flex volume file or LUN, and they leverage snapshot technology. You all are likely very familiar with flex clones. Some of the benefits are the space efficiency, the rapid provisioning, the cost savings. Flex clones offer really significant time savings. The combination of snapshots and flex clones together can be a very powerful tool in optimizing any environment. So they're ideal for cases where rapid space efficient copies of data are needed without impacting the original data set or consuming additional storage. And honestly, when we're talking about storage, isn't that every scenario? So in this particular use case that I'll dig a little bit more into, this is a developer workflow, right? So this is folks that are looking to write code using additional applications that are responsible for version control. And that is not as important. So I'm going to leave that as kind of a abstract black box, because no matter what applications an environment is using, you can take advantage of all of the things I talked about and also flex clones. So in a workflow where a developer wants to begin work on a release, and they need to make local all of the source code that pertains to the changes that they are interested in implementing. There are a variety of ways that this happens, but very often there's some kind of copy, some kind of data movement that happens to get those files local to the developer so that they have their local copies that they can make changes to. And if a code base is large or involves a lot of large files or is distributed, if the developer is working in a geo-distributed environment and they have to contend with lots of network latencies, this process can take very long. So many workflows refer to these environments as user workspaces or developer workspaces. I worked in embedded development many years ago, and we used to use something called rational clear case. I don't know how many of you are that old. That was an old IBM product. And we called it units of work. There are all kinds of names for these kind of clients that are made available to developers for them to make their changes, but all of them require some copy of some set of files that the developer can then work on locally before they commit them to the larger collective branches or repositories or what have you. And so in the experience here with this particular case, that process alone was taking up to an hour. It was a really large code base. Lots of files needed to come down because in addition to making the changes, developers will need to do test builds. And depending on how that kind of thing is organized, they may need everything to do the test builds. And if they don't compartmentalize and be efficient, then they also need the test data as well. So this process was taking extremely long. And so imagine a developer is ready to start their process and they open the work, they want to create their workspace, and then they have to wait an hour. And they have to go do something else. It messes with the continuity. It's distracting. It's not a good experience if you're a developer. In addition to that, the build times themselves were really long. And so this impacted the ability to rapidly create builds, which means that changes aren't getting tested as frequently. Developers aren't able to integrate. Whole releases aren't able to perform any quality control until new builds are made available. So these kinds of bottlenecks cascade and create overall time to market issues, because all of this time that folks are not able to do this work, to test, to develop, results in longer time to get features out the door into the market. And you compound that with large distributed development teams, and this just makes it worse. So one of the solutions is flex clones. And in this particular solution, there's some source code repository, and the team was already implementing automated builds, which the clients that hosted those builds already had the complete set of files needed for that release. So any file that would be needed by a developer to make changes going forward was present, plus the bits of the actual build itself, plus the test data, everything for a release branch. Anything that a developer might need in a unit of work would be all together. So the idea here was, once a build was made, how about you clone that environment immediately? The snapshot's already happening, so you take a clone of the snapshot and you kind of bank that, and that could be used to serve any requests that came from a developer for that particular build. And in this environment, the way the kind of the branch management and the iterative development was managed is that there's a build available every day. If tests needed to be done on a particular release, then much of the tests would be done on the latest build for that release branch or for that release version, so that everyone in the environment is using the same build. And so any issues that are reported, we can all point to the same build. And because of that kind of consistency in practice, then cloning the client that has all of those files and the build is the way that you would serve developer workspaces to the developers. There's never a need for them to have a different version or view of the code base, because everyone's working off the same, everyone working within a release is always working off of the same collection of files and builds. And so you can pre-populate these clones into kind of this pool that can then serve workspace requests. And so anytime then a developer would request a new workspace, they could just pull from this pre-populated set of clones that are ready to that have been previously created based on the last known good build. And again, right, this requires some investment. This requires knowing your environment. There's some upfront costs. But once you standardize and implement this and use automation to make it seamless for the developers, this results in a really good developer experience. And so with the initial introduction of the Flex clones, developer workspaces reduced significantly. And the ability to produce regular builds to keep the automated test workflows going increased significantly. And it is through solutions like these that organizations are able to achieve some of their continuous deployment goals as well, because the more frequently you're able to make latest changes and builds available and test them to the level of quality required for deployment, the more frequently you can deploy. Another key indicator of good developer experience is frequent deployment. Back in the day, for some of you that may remember this, you could work on a feature and submit it, and you're done, you've moved on, and then that release didn't go out for 6 months later. And any issues that came up later, 6 months later, you kind of have to press rewind if you need to triage that and go back and address that. And that is also disruptive and disrupts continuity, and developers report that as being a low developer experience. But if I'm able to deploy more frequently, if I'm able to, get some velocity around my work, that's a richer developer experience, and all of these contribute to higher quality software and faster time to market. And just as an aside, incremental builds, which are some organizations, and this one in particular, would create new builds throughout the day, so that all check-ins that were happening throughout the day, because there's one good build at night, all check-ins that are happening throughout the day, you don't wait until the end of the day to find issues. So interim builds, incremental builds are also going on, running tests, running continuous integration tests. Those builds also benefited from this implementation of flex clones, among other features. So real actual gains realized from integrating flex clones into the environment. And I touched on this a little bit. So continuous deployment can also benefit from flex clones, not just in this pre-population of developer workspace example that I shared, but also in the ability to rapidly clone production environments into staging, rapidly clone test data sets into from production into test environments for repro. So if there's some issue that's encountered and you need the specific configuration and test data to reproduce the issue, Flex Clones enables a really seamless way to do that. And if you've ever wrestled with attempting a repro, that's really, really super valuable. It enables parallel development and testing. So you can spin up multiple staging environments at the same time, multiple test environments at the same time. And this is not just for, you know, virtual machines and hardware. This also applies to containers. So I didn't talk a lot about containers specifically, or the configurations, hardware configurations at all, or the specifics of the applications we're talking about in terms of the software that's being produced. And that's because it doesn't matter. With the right knowledge and tools and automation, you can employ any of these practices for any of these types of environments or applications or technologies. So with Trident and persistent volume claims, you can benefit from flex clones just like you would for, non-containerized environments. And this is very powerful in the cloud, where for organizations that are comfortable and have deployed their CI/CD pipelines in the cloud, the ability to rapidly produce duplications, replications of their deployment environment is really important, and can be very powerful and even faster than it can be on premises. And it also is the savings, the cost efficiencies are a lot more powerful as well, because you have minimal footprint for those copies as long as they don't deviate from the origin. And they really provide this productivity, this optimization, but they're still isolated. So giving you all the power and flexibility that you need to really supercharge your development environment. Okay, so a little bit of the knowledge, but automation is key. I said this earlier. If you had to manually implement these things into the environment, it just is not useful. It's really important that you standardize on practices, which requires you to really understand what is needed to improve a developer experience and optimize your pipeline, and then to come to agreement and understand which of these practices make sense for you, and then also to understand exactly how you want to tune and configure this. So standardizing on these things up front when you create an environment is really important. The fact that these solutions are flexible and scalable is really useful, because it means that it doesn't require so much revisiting, just that you monitor your performance and make sure you make adjustments when necessary, because software development organizations and code lines, they're dynamic as well, and they grow all the time. But a key part of taking advantage of any of these features and more is automation that's available. And just like cloud and Gen AI have evolved, automation has evolved as well. And it's moved from a nice to have, extra credit kind of thing to a necessity, right? You cannot realistically provide any support any enterprise software development environment without key automation, well running, well supported, standardized automation. And so you may all be familiar. We have lots of automation assets available. We obviously have REST API support. Some of you are familiar with Zappy. Hopefully everyone is off of that and into REST now. There are lots of ways to streamline and automate your ONTAP systems, but I do want to call out a few developments that have happened in our automation portfolio, just to make sure everyone is aware and can communicate and evangelize these things within your own communities. I did a session on ONTAP Terraform Provider not too long ago, and folks weren't even aware that NetApp made available an ONTAP Terraform Provider. So I'm calling that out here. We do have an ONTAP Terraform Provider that is available in the Terraform registry. And for some workflows, we have samples available on the NetApp GitHub. They're public. There's a lot of functionality in there, and we actively add more to it. And this is a good way to, to implement some of the things that we talked about. If you are using FSX, AWS FSX for NetApp ONTAP, our ONTAP Terraform Provider does work for those configurations. There's some functionality that you will also have to use the AWS FSX Terraform Provider in conjunction, but it's just, it's very simple to do this, and there are examples of that available in our GitHub repo as well. So definitely check those out if you make use of Terraform. That can be something that can easily be integrated into your environments. Most of you should be familiar with the NetApp Ansible collection, and that continues to evolve and grow and be supported, and is a great way, again, to use some of the stuff I talked about earlier. And also, if you didn't know, if you need a reference guide to other ways to programmatically implement improvements, storage optimizations, or just interactions, your storage workflows. We do have a developer hub at NetApp. The URL is there below. You can go to netapp.com/developer or developer.netapp.com. And there is a list of SDKs and automation samples by product. So that can be useful in your endeavors if potentially. And just a few references here. We can definitely make these available afterwards because it's can be useful to read up and see what other organizations are doing. And again, anything I talked about is well documented in NetApp documentation online. So definitely check those links out. And if you have questions in the interim, there are several ways to reach us, but hopefully all of you know that we are on Discord. It's very well organized. So there is a group for Terraform, there is a group for Ansible, there's a general group. So there's a rich community on there with experts and knowledgeable folks ready to answer your questions. So I think that is what I had prepared for you. Any questions, any follow-ups? Yeah.
There are a couple questions.
Okay.
So the first one, is there a best practice for number of constituents to number of volumes when using flex groups, like aggregate size?
Yeah, so this is going to be very specific and dependent on your environment and your monitored performance. But the best practice is to start with a minimum of 4 constituents and to scale up in powers of 2. But again, you will need to monitor the performance and again, look at your documentation, and you can tune from there to ensure you're getting the optimal performance.
Okay. So my second question, large dev teams could push flex clone numbers up high up there. Are there performance considerations for flex clones?
There are. but most organizations tend to not venture into that territory. Flex clones are bound by the origin volume, as well as snapshots underneath. So it is, you do have to be mindful of any changes, any write-heavy intensive load to the origin volume, or any deleting and manipulating of snapshots that could potentially affect the performance of the flex clones. We don't see that happen very often. And again, with all of these solutions, it's important to make sure performance is being monitored, to make sure things that need to be tuned get attention.
Okay. And then final question for me, does the NetApp ONTAP Terraform provider work on Amazon FSx for NetApp ONTAP?
It actually does. We've been expanding that functionality. And this is a space where I think feedback is really helpful and useful, right? So how we try to approach this, for the most part, like I said, what you do on-prem and what you do in the cloud is both solutions are available across those environments. But things like ONTAP Terraform provider functionality is most useful when we implement the end-to-end solution. And so I'm very interested in the experience of users and how they're using these assets. So yes, you can absolutely use the ONTAP Terraform provider, but it's important to us that we get feedback for, okay, we have a deep and rich and long history of understanding on-premises users. Is that useful for our folks running FSx for AWS FSx for NetApp ONTAP in the same way, or are there cases where they have a need for a different kind of functionality or additional functionality that they could make use of our Terraform provider in the cloud? But things like setting up these flex cache relationships and just general setting up of your environment, all of that you can do with the Terraform provider, or fill in the blank with your own automation or with Ansible. So it's very streamlined, and it's nice because you don't suffer unused technical assets and having to separate and have one set of tools for your on-premises environment and entirely another set for your cloud. You can really streamline that and simplify using one set for both environments.
Well, I think that is all we have. Mekka, I really appreciate you taking the time to share this with all of us. There are 3 questions at poll questions at the end. I encourage you to take them. And I believe that is it. Thank you, Mekka.
Thanks for having me, and I'm happy to come back anytime, talk more about this or other stuff I'm working on.
We appreciate it. Thank you very much.
Take care.
All right. Bye.
Bye-bye.